Broken DMVPN between DC and branch 3 and 4. Correct the configuration issues resulting in broken DMVPN tunnel between DC, branch 3 and 4 according to these requirements. See what the statement says. Correct the configuration issues means there is something incorrect. There is something incorrectly configured. So you need to correct it. The DMVPN must operate in IPsec protected phase 3 mode. What do you mean by protected phase 3 mode? What do you mean by phase 3? Basically, DMVPN works as a hub and spoke. Okay. But when you enable phase 3, what happens? The spoke to spoke communication will also be enabled. Okay. Spoke to spoke communication. Using the VRF approach, safeguard the DMVPN operation against any potential recursive routing issues involving the tunnel. Do not create any new VRFs. Do not change the tunnel source command on the tunnel interface. On spokes, do not add new BGP neighbors. Reuse those that are currently up while changing their VRF membership as needed. It is not allowed to modify configuration on DC R24 to complete this entire task. So basically, where are these devices? Your hub is over here, R24, and your spokes are your spokes. R61, R62, and R70. Okay. Now, in DMVPN, the rule is that you need to configure, means your what do you say? Your spoke should have similar configuration as your hub. So what we will do, we will say on the hub side, we will take the output of interface tunnel 0. Also, we will take the output of crypto. Show run pipe section crypto. Okay, so here I'll take the output of this. I'll paste in a notepad. Then I'll go and take the output of these crypto policies. I'll increase the font so that it would be easier. Okay. Now what I'll do, I'll go on R70 first. R70 is my single host. So I'll go over there and I'll open it. Single spoke, you can say. So I'll start with this. So run interface tunnel 0. I'll compare my tunnel of R70 with R24. So first of all, we will see the tunnel IP. Tunnel IP is there. Here also no IP redirect. Here there is MTU configured. 1440 is the MTU that is configured. 1440. Okay. So here we have configured MTU 1440. Here there is no MTU. Okay. So the first difference is we need to configure MTU. So we will go under the tunnel interface tunnel 0. We will say IP MTU 1440. Okay. Then what they have said in the question, they have said that do not add new BGP neighbor. Use this that are currently up while changing their VRF membership. Okay. Now, this R6 and R70 are forming neighborship under VRF WAN. Okay. So if you say do show IP BGP. Show VP, VPN, V4, unicast, all summary. They are forming neighborship. Okay. This neighborship is up and they are forming neighborship under VRF WAN or VRF WAN. Okay. And if you see do show run interface, do show IP interface brief. If you see gig 0/0 has two sub interfaces. Gig 0/0, which is connected to R6 through which my traffic will flow, has two sub interfaces. Your encryption, authentication and group is there. Hashing is not there. So what I said, you need to match the configuration of your hub. So what I'll do, I'll go on this, under this crypto ISACM policy, and I'll say no hash MD5. Once I remove this, you see do show DMVPN. Currently it is not up. Give it some time. Do ping 10.2.250, sorry, 10.200.0.1. Let me check one thing. IPOSPF neighbor. Ping under VRF WAN. See, my DMVPN came up. It took some time, but it came up. You can see over here, state is up. Okay, I'm able to reach the tunnel IP. So my tunnel state is up now. Okay. Now same thing you have to do with R61 and R62. Now before proceeding with R61 and R62, we need to check some details. We need to check show run interface gig 0/0. If this is a part of VRF WAN, so this is not. Also loopback 0. So basically you have to take output of these two commands and show run pipe section router BGP. These three commands you have to take output and you have to keep it ready. Okay, this is what it will help you. How it will help you? Interface gig 0/0. Now this should be a part of VRF WAN. Where is gig 0/0? This is this interface which is connected to R5. So I'll say VRF forwarding WAN. Now once I say VRF, once I make any interface, it will lose its IP address. So I can just copy the IP address from here and paste it. Then interface loopback 0, VRF forwarding WAN. It will also loop the IP, lose the IP. So I will go and copy from here and paste it. Then if you see over here, the neighborship is that the neighborship is not formed under the address family VRF WAN. It is outside. So what we will do? We'll go under address family and the router BGP. We'll go under address family and we will say we'll add these two commands. This is how you can speed up your configuration. Okay. Now my neighborship will come up. See, my neighborship came up. Now we need to check the interfaces. To show run interface tunnel 0. Now here also there is no MTU. So first you need to configure MTU. So go under IP MTU 1440. Also tunnel VRF WAN. Okay. Now there is one more thing on R61. If you see this, let me go on R70. Do show run interface tunnel 0. And if you take output of this and paste it over here. Okay, if you see over here, let me go to R61. Keep this beside. If you see the mapping over here, IP NHRP map. First is the tunnel IP, then the map server IP. But if you see over here, the first is the map server and the second is tunnel IP, which is wrong. It should be in this way. So what I'll do, either I can remove it and then add this one, or I can just add this one. No need to remove. Okay. Now if I go on R70, do show run pipe section crypto. Copy this crypto configuration. Paste it over here and go to R61. Do show run pipe section crypto. Now here if you see the crypto configuration, here there is static key configuration. What I said, if you are forming neighborship over the WAN, if your traffic is going over the VRF, then you need what? You need keyring. Okay. So here we need to configure keyring. Now here also there are two ways. Either you can remove the static key configuration and then configure the keyring, or you can directly configure the keyring. So I am directly configuring the keyring. Then the second thing, here if you see there is hashing enabled, I need to disable hashing. So what I'll do, I'll go under the policy. I'll go under the policy and I'll say no hash MD5. Once I do this, do show DMVPN. To run pipe section crypto. Pre-shared key is there, VRF keyring, here hashing is not there. See, my tunnel came out. It takes some time, but the tunnel comes up. Just give me a second, guys. So Sinade, if you see in the question, they have said it is not allowed to modify any configuration on DC R24 to complete this entire task. That is the reason we are not adding hash on the hub. Okay. Now similar configuration you need to do on R62 as well. Same. Take the output of show run interface gig 0/0, show run interface loopback 0, show run pipe section router BGP. Okay, then interface gig 0/0, VRF forwarding WAN. Then take the IP from here, paste it, interface loopback 0, VRF forwarding WAN. Take the IP from here, paste it. Then go under router BGP, address family, paste these two commands, inform neighborship. Now do show run interface tunnel 0. Here also there is no MTU. So IP MTU 1440. Tunnel VRF WAN Okay. Now here the mapping server is correct. So no need to add the mapping server. Here the mapping is correct. Then you need to go under the, you need to configure this thing, the key ring, and you need to go under the crypto ISAC and policy. And say no hash MD5. It will take some time. See, my tunnel came up. Now it is forming R61 and R62 are forming neighborship over EIGRP. Do show DMVPN. My DMVPN came up. Also R61 and R62 are forming neighborship over EIGRP over the tunnel. But R70 is not forming. Got it? Any questions, anyone? There is no wrong map on R62. Mapping is correct on R62. Okay. Okay. So let us start with 1.12. Tuning EIGRP on DMVPN and DMVPN enabled sites. Optimize the DMVPN operation according to these requirements. Ensure that branch 3 and 4 receive only a default route over EIGRP in DMVPN. The default route origination must be done on our DC R24 without the use of any static routes, redistribution, or route filtering. Redistribution or route filtering. It is not allowed to modify the configuration of R61, R62 in branch 3 to accomplish this task. It is allowed to add commands to the configuration of R70 in the branch 4 to accomplish this task. None of the existing configuration on R70 may be removed to accomplish this task. So basically what they are saying that on these R61 and R62, if you see do show IP route EIGRP, here you should only see a default route over the tunnel, but here you are getting these 14 dot loopbacks also. Okay, so you have to remove these and you should only get a default route over the tunnel. So for that, what we are doing, we are going on R24 under EIGRP under address family unicast OS number 65001, and I'm saying AF interface tunnel 0 no passive, and I'm saying summary address 0.0.0.0/0 and AF interface loopback 0 shutdown. So once I shut down the loopback 0 interface, what will happen? It will not get advertised. So I'm going over here, copying this, going to R24. Now if you go on R61, do the same thing. Now you will see you are getting only a default route over the tunnel. Only a default route over the tunnel. Now if you see on R70, do show IP route EIGRP. You're not getting anything. If you see do show IP EIGRP neighbor, it is not forming neighborship. Now why it is not forming neighborship? If you see do show run 5 section router EIGRP, here you will see the AF interface default is configured as passive. So what happens when you configure AF interface default as passive? All the interfaces will go under passive, and passive means no neighborship. So my tunnel interface is also going under passive. So I'll say AF interface tunnel 0 and I'll say no passive. Once I say no passive, see my neighborship came up over the tunnel. And if I check now, do show IP route EIGRP, I'll only get a default route over the tunnel. Got it? This was your first point. First part, you can say. There are two parts. This was your first part. Second part. Configure switch 601, 602 at branch 3 according to these requirements. Router 61 and 62 must not send EIGRP queries to switch 601 and 602. Now, what do you mean by EIGRP queries? When does a router send EIGRP queries? So basically, I'll just explain you in short. This is a router. These are end routers. Okay, one is connected over here. One is connected over here. One is here. One is here. And there is one more router over here. Okay. This is router 1. This is router 5. Our routers 1, 2, 3, 4, 5, 6. Okay, this is 2. This is 3. Okay, now these are my random routers. Now, this is my source and this is my destination. So, how many paths are there from source to destination? I have 2 paths. So, in EIGRP, what happens? It selects the best route and a second best route. So, suppose in this, we have this is as the best route and there is no second best route. And the best route goes down. What the router 1 will do if it wants to reach the destination? Router 6. What it will do? It will send out EIGRP queries to all the neighbor. Okay. Now these are the neighbor. These are devices. They want if they want to go anywhere in the network, either they want to go to router 2 or router 6 or router 3. The next stop is what? Router 1. So these routers will never know that if I want to go to R6. They will never know how to reach because R1 itself doesn't know how to reach R6, router 6. Okay. So when these routers will get EIGRP queries, this router will send a reply for a query. Yes, I know how to reach R6. Okay. But these router will never reply because these routers do not know how to reach R6. So what this router will in EIGRP, if I'm sending a query message to 4 neighbors, unless all the 4 replies, I will not decide the best route. So these router will never send a reply. So my router will go into stuck in active state. So it will never select the best route. It will stuck in active state. Okay. So to overcome this problem, what we do, we know that these devices, they want to go anywhere. They have to come to me only. So what I will do, I'll make these devices as stub. So once I make these devices as stub, there will be no query messages sent over here. There will be no query messages. Only it will go to this router, and once the reply comes, it will select this route as the best route. This is something EIGRP query. Okay, so router 1, 61 and 62 must not send EIGRP queries to 601 and 602. That means they want that 601 and 602 should be acting as a stub devices. Stub devices. Switches 601 and 602 must allow advertising any current or future directly connected network to R61 and R62 after the network is added to EIGRP. Switches 601 and 602 must not continue to must continue to propagate the default route received from R61 and R62 to each other. To select the default route, use a prefix list with a permit type entry only. What they are saying basically, whatever the default route is received from these devices, now these devices can exchange the default route between each other. Switch 601 and 602 can send the default route between each other. But switch 601 and 602 must not propagate the default route back to R61 and R62. If the prefix list that allows the propagation of selected EIGRP learned networks between switch 601 and 602 is modified in the future, the same set of networks must be disallowed from being advertised back to R61 and R62 automatically without any additional commands. What they are saying, see, this R61 is sending default route to both, okay, and they are exchanging the default route. Now suppose I'm not getting default route from R62. Now they are neighbor, R62 and switch 602 is neighbor, EIGRP neighbor. This should not send the default route back to R61. We have to block the default route to go from switch to router. Either it should receive from R61 or over the tunnel. It should not receive from the switches. Okay. So let us go to the solution part. For that, what we are doing, we are going on switch 601. We are saying we are creating a prefix list def. Okay, and we are saying permit default route. Then we are creating a route map def. Okay, I'll rename this as A, so it will be clear. Defa and route map is def. Permit 10 match IP address in prefix list defa. So what is the IP address? Means match the default route. And here you are saying deny. So here you are saying route map no, deny match IP address in the prefix list and permit all the others. And where you are applying this, we are applying the route map def as a leak map, okay, while configuring EIGRP stub. We are saying use this default route. And we are creating a distribute list and we are saying route map. We are applying this route map no in the out direction of gig 0/1 and 0/2 on both switch 601 and 602. So we are applying on this interface to deny the default route, go out of these interfaces. Understood? Okay. So we are. So I'll not paste this. I'll just first of all I'll just paste this command. I'll not paste the distribute list. First I'll show you that how the default route is coming. Then I'll show you how it will get blocked after applying the distribute list. Okay. Now what I'll do, if I see do show IP route EIGRP, here you will see I'm getting a default route and from gig 0/1 and 0/2 2. Okay, now what I'll do, I'll make this link down. This link means my tunnel will go down. If this link goes down, my tunnel will go down. Let me go on R61. You'll see my tunnel went down. To show DMVPN. Okay, it is up now. See, my tunnel went down. Okay, my tunnel went down. Neighborship over the tunnel went down. Sorry. Neighborship over the tunnel went down. Now, if you see, do show IP route EIGRP. Here, see, you are getting the default route via gig 0/1 from here, from R62. If I shut down this link also, now my neighborship between R61 and R62 is down. Now, if you see, now I am getting default route via gig 0/2 and 0/3 on R61. Means these devices are getting default route via switches, which should not happen, which we need to stop. So for that, we are adding these distribute list. Once I add the distribute list, now I will show you the output again. Now you see, there is no default route on R61. But if you go on switch, do show IP route EIGRP, I'm still having the default route and it is learned via gig 0/1 from this. See, R62 is getting the default route over the tunnel. R62 is getting the default route over the tunnel and it is advertising these switches. But the switches are not sending back to R61. Got it? Once I make these links up, I should have default route over the tunnel. Got it, guys? This is your task 1.12. Any questions, anyone? Okay, 1.13 is your IPv4 networks in legacy branches. On switch 211 in DC, complete the DHCP configuration according to these requirements. Create IPv4 DHCP pools named BR3_V2000 and BR3_V2001 for branch 3 VLANs 2000. Use this subnet 10600.0/24. For VLAN 2001, use this subnet. Create DHCP pool name BR4_V1 10710/24 on branch 4. Okay, just give me a second. I just forgot. Thank you, Sandesh. So this distance command, this is not used in this task, but this we need to configure in this task so that we get a correct output in the 1.16 task. Okay, this is required for 1.16 task. Okay, this is not used over here, but we need this for 1.16 task. So we need to configure this distance command. Okay. In each subnet, assign addresses from .101 up to .254 inclusively and the appropriate gateway to the client. So here we need to configure DHCP server. Simple configuration. I will exclude first 100 IP addresses branch 3 VLAN 2000 network default router. Exclude branch 3 VLAN 2001 network default router. Branch 4, this we need to create on switch 211, which is the DHCP server. So I'll go on switch 211. Nothing much to explain in this. It is self-explanatory. Coming to the second part. Now here we need to configure HSRP. So on branch 3, complete and correct the configuration on switches 601, 602 and 610 to allow HSRP and DHCP relay operation in VLAN 2000 and 2001 according to these requirements. HSRP must implicitly use the virtual MAC address range 0000C9F through 000 this range. Okay. Now in HSRP, we have two versions, version 1 and version 2. Version 2 uses this range. So indirectly they are saying us to use HSRP version 2. The group member must be 100 for VLAN 2000 and 101 for VLAN 2001. Switch 601 must be active gateway for VLAN 2000 with a priority of 110. The active role ownership must be deterministic. Switch 602 must be active for VLAN 2001 with a priority of 110. The active role ownership must be deterministic. Each gateway switch must track its uplink interfaces, gig 0/1 and 0/2. If either of these interfaces goes down, the active switch must allow the other switch to become the active. However, it is not allowed for the tracking to modify the HSRP priority to accomplish this requirement. Basically, this task is similar to your VRRP 1.3 task. So they want that this is the gateway for VLAN 2000 and this is the gateway for VLAN 2001 users. Okay. Now they want that you need to track these uplinks 0/2 and 0/1. If any one of these goes down, if suppose this goes down, the gateway role of VLAN 2000 users should be given over here. But they want that the priority should not be decremented. So cover. So the priority is 110. By default, what happens? The priority gets decremented by 10 and the gateway role gets changed. But they want that this should not happen. So what we can do, I'll show you. Both switch 601 and 602 must be configured as DHCP relay agents in both the VLANs 2000 and 2001, pointing towards the DHCP server 10.2.255.211 at switch 211. However, at any time, only active router in the particular VLAN should relay the DHCP messages. So switch 601 and 602 will be your relay agents. Place host 61 and host 62 into VLAN 2000 and 2001 respectively, and make sure they are assigned their correct IPv4 configuration. It is not permitted to use any kind of scripting to complete this task. So basically what we are doing over here, first of all, we are going on interface switch 601 interface VLAN 2000. We are saying standby version 2. We are assigning standby 100 IP address 10600.1. Then standby 100 priority is 110. Standby 100 preemption. Now why we are enabling preemption over here? Because it said active role ownership must be deterministic. Deterministic means automatically original gateway should get the charge back. Interface VLAN 2001, standby version 2, IP and preemption. Then we are creating two track objects, track 1 for interface gig 0/1 line protocol, track 2 for gig 0/2 line protocol. Track 3, we are creating a list, boolean, and we are using an AND operator. Now AND over here means OR. Previously in VRRP task, we were using OR because they have said if both the interface goes down. Here they have said if either of the interfaces goes down. Either means any one. We are using if any one object goes down, then the track list should be down. Then we are going on VLAN 2000. We are saying track standby 100, track 3. Now we are using one more command over here, shutdown. Now if you remember, I said by default what happens, the priority value gets decremented by 10. If you give this command, shutdown command, okay, what will happen? The priority value will not get decremented. It will be the same. The group will get shut down. The group standby 100 on this particular switch will get shut down. So now if the group is not running, it will automatically give the gateway charge to the other switch. Okay. Now we are creating named HSRP for DHCP redundancy. So we are giving a name to HSRP 100. We are saying 100. You are having a name as HSRP 1. IP helper address 10.2.255.211. For redundancy, search for HSRP 1. Same we are doing for VLAN 2001. Here also same thing. Got it? This is for switch 601. Now for switch 602, we are doing the same thing, but here there is a standby 0 configured for VLAN 2001 with the same IP address that we need to use for standby 101. So first we need to remove it. No standby 0. Then we need to configure standby version 2, IP, priority, preemption. For VLAN 2000 only IP and version and preemption. Creating track objects, track list, and tracking the objects over here. Similar configuration like your switch 601. Switch 610, we are going and we are making the uplink interfaces trunk, and we are allowing VLAN 2000 and 2001. So 2000 is already allowed in the pre-configuration. So here we are allowing only 2001. Okay, then we are assigning gig 0/0 is connected to R61, which is part of VLAN 2000, and this is connected to R62, which is part of VLAN 2001. So we'll go on switch 610. Okay. Now if you go on the host machines, now these will be Linux PCs in the exam like your host 11 and 12. But on this server, I have configured them as VPC to optimize the performance of the lab. So here I'll say IP DHCP. I should get an IP address from the DHCP server. I'm not getting. Okay, I got it. Dora process 10600.101 R61. R62 will get this should get in the range of VLAN 2001 IP DHCP 10611.11. Now to test the gateway redundancy, first I will show you the do show standby brief. This is the active router for VLAN 2000 with a priority of 110. On switch 602 do show standby brief. Here you will see active for VLAN 2001. Now for testing, what I'll do, I'll make this link down. Once I make this link down, the active role should be given to switch 602 for VLAN 2000. You check. See, it is active for both the VLANs. But if you see over here, the priority is still same. The state which it went is initialization state, but the priority is still same. Still the active gateway got changed. Now once I make this link up, switch 601 should get back its original active role. See, listen to active. It got back its active role. Got it? This was your second part. Any questions? Third part. On branch 4, complete the configuration of router R70 according to these requirements. Assign IP address 10711/24 to gig 0/2 interface. Enable DHCP relay on this interface and point it to the DHCP server 10.2.255.211 at switch 211. It is allowed to add one additional missing command to R70 configuration to allow DHCP clients connected to gig 0/2 obtain their IPv4 configuration. Make sure hosts 71 and 72 are assigned their correct IPv4 configuration. So this interface, the LAN interface, is not having. Yes, you can use Notepad. The Notepad in the exam is known as Genie, Geany, Genie. So this interface is not assigned any IP address. So you have to assign IP address and you have to advertise that particular network in EIGRP. I'm advertising that particular net 10710 in EIGRP and configuring helper address. Okay, now if I go on R71, if I say IP DHCP, R72, IP DHCP. Here I got an IP 1071.101. Here I'll get an IP 1071.102. Got it, guys? Is it clear? Anyone, any questions? Okay, let us stop over here for today. Let's meet. Yes, Pooja, tell me.